1 liter equal to how many meter cube?
So, please ask the question again.
What is the conversion factor between a liter and meter cube? 1 liter equal to how much meter cube?
So, 1000 meter cube.
All right. Is it? 1 upon 1000. 1 meter cube is equal to 1000 liter, na? Hmm. 1 meter cube is equivalent to 1000 liter. Therefore, 1 liter will be equivalent to 1 upon 1000. That is, that you can write it as 10 to the power minus 3. Okay, Devansh?
Yes, sir.
Okay. Charu, unmute yourself. Charu, are you able to hear me?
Yes, sir.
Yes. Charu, can you tell me, in this question number 7, it's giving you the volume, all right? And the lower part, it is giving you the density of water. Now, can you tell me how we can use this? Because in the formula of work done, here we will be calculating the work done. So in case of work done, it is mgh because the water pump is raising. But m is not given. How to find out m? And this question is to all over here. If you observe, it's the volume of water and the density of water is given. How can we use it to find out the mass of water? Yes, Charu?
I don't know.
Charu? You don't know? Eh? Okay. Anybody? You can write down in the chat. Yes. Kana has written right. Shakiba also. Divyanshi also right. Yes, Harshit, Anshika, Mudit. Parth. I hope you that symbol is rho. Okay. Yes. Good. So we move to the solution part. So in this case, question number 7, we have been provided with the volume of the water, that is 50 liters, all right. Now we all know that 1 liter is 1 meter cube is equal to 1000 liter, and therefore 50 liters will be equal to 50 into 10 to the power minus 3 liters meter cube. Here what we are doing, we are converting it into SI unit. Okay. Generally we are using it for the density. Height is given as 25 meter and time is given as 5 seconds. The first part, it also gives you the value of G as 10 Newton per kg, and the density of water, that is rho, that is equivalent to 1000 kilogram per meter cube. Now if you see the unit of density, you find that it is in meter cube, and therefore the volume should also be in meter cube. So that is the reason why I have converted it into meter cube. Now we all know that the first part it is asking you to find out the work. Sorry, not first part. Uh, my mistake. I saw the eighth one. Okay, so now it is asking you to calculate the power of the pump. Now power P. Keep in mind P and rho are two different. So this is P. Power of the pump is equal to work done upon time. Okay, and work done because the water is going to be lifted up. So this will be your against the gravity, that is mgh upon T. Now for M, we have the volume of the water into density of water multiplied by G multiplied by H upon T. So this factor, if you observe, this portion basically is providing me with the mass. Alright? So now we will be putting the values. I'll just rub out the upper portion where I have written. So now if we try to take, this will be equal to, the volume is given at 50 into 10 to the power minus 3 into your density 10 to the power 3 into G, that is given as 10, into H, that is given as 25 meter, divided by the time, that is 5. So this will automatically will cancel by this, and keep in mind we are not dividing. Actually, when negative and positive power same powers are added, it will become 10 to the power 1, 0, that is equivalent to 1. And here if we cancel it 2 times, so 50 into 50, 200, 2500 watt. So this will be your answer. So I hope this question is clear to all of you, and similarly we will be doing some other questions also. Question number 8. If you have done this, you can note it down also, and then you can tell me. Now, question number 8, meanwhile I'll read through. A pump is used to lift 500 kgs of water from a depth of 80 meters in 10 seconds. Now here you have to calculate the work done by the pump, the power at which the pump works, and the power rating of the pump if its efficiency is 40%. Here also G is given as 10 meter per second. Now generally efficiency, when we are calculating, and efficiency is generally been calculated as the total input upon how much is your, what is the part you are using it. So useful work or useful power upon your total power input, and if you multiply by 100, that will give you the efficiency in percentage. Okay, so in this case we will be calculating it. Just clear this. Number 8. A pump is used to lift 500 kg of water, so the mass of water comes up to be 500 kg. From a depth of 80 meter, height comes out to be your 80 meter. Time is 10 seconds. Okay. the efficiency is given as generally we denote it by neta. That is your 40%. Now, the efficiency factor we will be dealing with a bit later. So that is given as G is given as 10 meter per second square. The first part it's asks you is the work done by the pump. So work done by the pump will be your against the gravity, that is mgh. This is equal to 500 into 10 into h is 80, and this comes out to be your 5 8s are 40, and then 2 3 4 4 zeros more, or we can express it as 4 into 10 to the power 5 joules. In physics, when you are solving, you can express the power of 10 in an exponential form also. So that is also in a standard way to solve these questions. Then we have the power at which the pump work. So to find out the power, so power is equal to work done upon time, that is work input, that is your 4 into 10 to the power 5 upon the time which it takes is your 10 seconds, and as a result it's 24 into the power 4 watt. Or if you want to change it into the higher units, as we can do it, it can also be written as 40 kilowatt. K will be small, W will be capital. So this was about the power. Now the main part comes out. If the efficiency is this much, then how much is the power? Keep in mind the above power which we are getting, that is if we consider that the 100% efficiency is taking place. So 100% work gets converted into your power. Okay, but in actual practice, you will find that the efficiency of the machine is not 100% because there are various reasons like frictions to overcome the friction, and the other thing, the work which has been done by the machine or the power of the machine by which it is trying to do, that is going to be decreased, and that is why we calculate the efficiency. So if we are saying a machine is 40% efficient, that means the energy conversion which is taking place, that is only 40%. That means only 40% of the work is a useful work. Okay, rest 60% of the work is being utilized to overcome the other forces like force of friction and other things. So here, if we have to calculate the efficiency, if I use the simple neta for the efficiency, so that is given as 40%. So this we can write down as useful power, power useful divided by the power input. Now, so the power input which we are calculating, that is power input which we have done. That is your 40 kilowatt of power can be generated. Okay, and here we have to find out the useful power which is present over there, that is your 40 kilowatt. This is the work which is getting converted into your power, or this power will convert this much work into your useful work. And therefore what we calculate over here is your power input. Now since efficiency, so it is given in percent, so multiply with 100%, so this gives you a percentage. So what we have to calculate is per input, and that can be power useful upon efficiency into 100. Okay, so now if we try to calculate this will more, you will be studying in detail about efficiency of a machine in the next chapter, that is your machine. So here now what we are going to do is power input, we can calculate it as useful power, that is given as 4 into 10 to the power so 4 into 10 to the power 4 upon your efficiency is given as 40%. So 40 into 10 to the power 2, that is 100. And when you get this, if you solve it, you will be getting it in kilowatt hour. That is, this will be your 100,000 kilowatt, or you can convert it into 100 kilowatt. All right. So if you have a problem, you can do it from here, and this is how you are getting. So this is what we are doing. So for today, we'll stop here. We'll discuss something else in between, because now we are having less time. Let's first discuss, is there any problem, or have you understood the things? You can write down your queries. Sorry, what is your problem? Sorry, Shivastava. I do not find many of you are joining over here. Sure. Unmute yourself. Sure. Shivastava. Okay, write down your problem on chat. Sure? Sure, are you there? Sure, yes, you can write down joule per second also, but a specific name is given uh, because uh, and that has been given as your watt, and therefore we are using the watt generally as an SI unit. So whenever it has been written, try to mention it with watt. Not exactly, but it is advantageous to write down watt only. Mechanical advantage and other things I'll told you that we'll study in detail in your machine chapter. Okay, so we'll come to that portion when we are studying the efficiency, because in this question I might get confused, and therefore we will be dealing with that in the next chapter, or maybe I'll write down and put it in the group. 8.3 again, Utkarsh are trying to calculate, and therefore in this case we are talking about height because the water has to be taken from the lower ground to the upper using the pump. I hope this is clear to all of you. Value wise you will say it is same, H or T. 1 kgf is equal to 10 Newton per kg, it has been given, and therefore we find that W is F is equal to M into G, so 10 into 10. Yes, definitely. We call it as somebody has got the mic on. Who is this? If you have a question, you can ask. Otherwise, you please switch off your audio. Okay. So Parth Kesari has asked this power that is not used will be wasted. Definitely. We have a concept of dissipation of energy where we say that the energy which is not useful. So in actual practice, when we are studying, we consider it as an ideal case and then we solve the numerical and everything. But actually, when the work has been done, okay, major portion of the energy is lost due to this dissipation. And similarly, when we are talking about the power, so definitely that power is also wasted, because it's not wasted in the sense that it is being utilized to overcome the force of friction and other resistive forces. But this is not a part of the machine what it is supposed to do, and that is why we consider it as the dissipation or wastage of power. So now the class is going to be over. It's nearly 1 minute has been left. Okay. So whatever other problems you have, you post them into the group. Your groups are still open. It will be open till 10 o'clock. Please, all those who have not submitted their work, their detail, please submit it. Okay. And the rest of the things we'll deal it in the through the group. Okay. Meanwhile, I'll also give you the numericals to be done and exercises. Please go through it. So, all the best, study, and please, all of you join the classes.